Tonight's speaker is Erik Schwartz from Elsevier. Erik has 25 plus years of experience in building search applications. This has included working for the Naval Research Lab in Washington DC, building enterprise search engines for a number of companies, including FAST and Microsoft, and leading the content discovery team at Comcast. In 2018, Erik came across the pond to take up residence in London with the role of Vice President of Search Experience and Application Services at Elsevier. Tonight he's going to talk to us about using applying machine learning to information retrieval. So without further ado, I'll hand over to Erik.
Wonderful. Thank you so much. Thank you, everyone, for allowing me to join you tonight and talk about my favorite topic, which is search and how easy it is to find things out in the world. So I did the same slide, but I think this is completely duplicated. I think what the interesting anecdote for me, just to start off and just to warm up a bit, is my training was electrical engineering. So when I studied in university at a small college in Hartford, Connecticut, not Trinity in Dublin, but Trinity in Hartford, Connecticut, I studied electrical engineering, and to keep myself busy and keep myself occupied and provide spending money, beer money for college, those college days, I worked at the computer lab, and that was about the time of the early 90s. So Mosaic was just coming out there. Netscape was just coming out there. And I didn't know at that time what the internet was going to be, but I knew it felt so simple and felt so connecting and so empowering that I wanted to pursue it. And so I ended up at my first job out of school was at the Naval Research Laboratory in Washington, D.C., right across from the airport downtown. And that was where it was the first time I ran into Elsevier, and who knew 25 years later my journey would take me full circle to working on the content and content problems that Elsevier is looking to hear. But I was working in a library, and the library was faced with some real physical problems. They had physical space problems. They had subscribed to journals, and they were getting journals from all the different publishers, and producing their own technical reports from the researchers inside the laboratory, but they didn't have physical space to store it. So we worked back then on digitizing journals, digitizing scientific journal articles, so that the researchers could find them and disseminate them on the laboratory. And so 25 years later, it comes full cycle, and here I am back in London, now trying to help Elsevier complete this digital transformation, and really build good experiences around search and finding the content that's important to these researchers and scientists. So the first thing I want to talk about a little bit is, what is a good search experience? And I walked into an area like Elsevier that's been serving the library community for a large number of years, and there's some very interesting emotion around what a good experience is. There are some folks that believe that we want explicit control. We know exactly how to articulate the queries. We know exactly how to spell out what we want. We want that explicit control so that when we ask the computing system for those documents, we get them all back. And we want that consistently. And that's been it's built into the DNA of that consumer, of that researcher, or that the librarian user, that digital worker for a long period of time. And what I want to talk about tonight is there are a lot of techniques out there that really can simplify that for the customers, that really can simplify that for the end researcher, that can really simplify that for the archivist and the librarian who wants to find information but doesn't need to spend their life figuring out how to program a computer to do that. And so when I talk about making really good search experiences, I fall on four major tenets. One is that the search results are really relevant. And I know that's, relevancy, it's relevant to me, right? And it's relevant to you. It's how do I know it's good, right? It's one of those questions. So I'll talk a bit about what really relevant means. What's really relevant, it's simple and conversational. It's authoritative and it's fast. And some of these last couple of tenets around a good search experience are because we've now seen what Google is. Everyone in this room, and please raise your hand if you don't know what Google is, right? That's a walk-in assumption. But we've all been retrained. We've all been retrained and reassigned to see what a search system is. And so we walk into it, we walk away from Google and walk over to the next system, and we say we want it to behave just like Google. And it's not a trivial problem. It's not a trivial problem. So we have to break it off into little bits. For everyone that wants to build a search experience, you can't just throw your documents into a search engine and have it just be really good. So let's break that. We're going to break that problem down a lot tonight. We'll spend some time thinking about that. And please, if you have comments, if you have thoughts, don't feel free to raise your hand or disagree or challenge. I'd love to hear the feedback. So, what does really relevant mean? When I think about relevance, it needs to be contextual. It needs to be contextual to me. And when we talk, right, and when I talk, and I say in a few minutes, I talk about the Naval Research Laboratory, or I talk about Elsevier, that has context for you. Because I introduced myself, I introduced my history, I introduced where I've been in my career and what I'm doing right now. And that history is how we think about when we have conversations. When we talk and we communicate with each other, that history is retained and we build on top of that. However, when I go and sit down in front of a computer and ask a question, that context is reset every time. So how do we make that contextual? How do I know that you work in the computer science department? How do I know that you have written papers about machine learning? How do I know that in your spare time you've dabbled in drones and airplanes, right? All these things put together your context, and that's a context that you have in your head where you're going to look for information, but the computer system doesn't have it. So how do we relay that context back into the system? So do we build that good experience? The next big point about relevancy is how do I understand your intent? What are you really looking for? And are you looking for? And I'll show you some examples of that in a few minutes. Are you looking for a recent article? Are you looking for something new? Are you looking for something that's seminal? Are you looking to just get started? Are you looking for something maybe in an adjacent field? How do I really allow you to express that intent in a meaningful way so that I can now get to the heart of what you're looking for and then give you good results? So relevancy understands your context, has to understand your intent, and what I'll argue is in the notion of science, personalization really helps. Because personalization allows me to look at what you've read in the past, what you've stored in your personal library, what I've downloaded, things that I've interacted with that are important to me, things that I've cited, things that I've used as references in my work are really important, and creating that personalized touch with a search experience drives relevancy up tremendously. So let's take a look at an example. This is Google Scholar, and this is just a simple query about machine learning algorithms. And so again, back to my earlier premise, we think of Google and we think of good relevance. But what's interesting here is one of the reasons I wanted to point this out is we could argue that the very first article, the practical Bayesian optimization of machine learning algorithms, is a really relevant result for a machine learning algorithm query, right? It's a really good paper. It talks about some of the really early stages. It's a little bit old, it's from 2012. But one of the things that's driving up that relevancy is the number of times it's cited. So, but what it wasn't able to express in this particular query was, am I looking for? Am I just getting started? Right? Do I want to know a history of machine learning algorithms, or do I really want to find the latest and greatest of what's being done today, or what are the latest advances? Right? That's not coming up at all. The next one is also has 16,000 citations. So Google Scholar is optimizing in its search algorithm towards citations, which ends up being very useful if you're doing a certain type of scientific research. But if I'm really doing a broad skimmer, if I'm really looking for the latest information in the field, or I'm looking for a way to, maybe I'm trying to figure out if there is research or an area of research that I could participate in that hasn't been completed yet. And this doesn't really tell me that at all. So I've got to go back and put that effort back on you as a consumer, as a user, to ask a better question, right? Yes?
I mean, there is a sort by date, at least, that partially addresses.
Yeah, sort by date is, in fact, some of the systems at Elsevier actually sort by date, and date is an interesting lever to be able to flip on. You have to be careful with sort by date because it does give you the most recency, but sometimes it acts as a filter, not necessarily a relevancy. So what you want to do is when we introduce date or as a freshness algorithm into the freshness for sorting, we want to make sure we use it as a boost to boost the most recent and newest stuff, not just filter by date or not just resort by date. So it's a bit tricky, but you're right. That's a way that a lot of people deal with that problem. Yes?
You could have the word survey.
Add survey, yes. That's precisely my point, right?
The user could do that using Google Scholar.
Yeah. You can go back, but the challenge here is that you have to know what word to go at, right? There's nothing here telling you here's a way to make it. Did you really want to look for the most recent things, or did you really want to? Yeah, it's a summary paper, it's a survey. So once you become expert with sort of that content, you know how to ask better questions. But if you're new to that space, how do you know? How do you learn that? But no, you're precisely right, and that's and did everyone hear that tip about adding the term survey? I mean, how many people knew that you could do that with Google Scholar? Yeah. So how do we share your experience with others so they can find that same experience? That's an interesting challenge. Yeah.
I'm sorry. What about for example, geometry? If I want to solve a problem and I want Google to help me, what can I do?
If you want.
So for geometry.
So you have a geometry problem that you want the answer to? Well, so first of all, I would not recommend going to Google Scholar for that. Believe it or not, if you take a geometry problem and drop it into Google, it's smart enough, and I'm actually going to talk a bit about why it does that. It's actually smart enough to give you examples of how to do it. What you'll end up finding if you go to Google itself is it'll find a YouTube video, or it'll find a training website. They'll tell you, oh, here's some more problems like this, right? I mean, it's maybe not so. Maybe your geometry is a little more complicated than most things. But but I wouldn't necessarily go to Google Scholar. But again, this becomes an interesting problem, right? Because you now, as the user, you've got to go figure out where to go to answer your question. Like Google Scholar is really good if you're looking just for scientific articles, because that's what's there, right? And so if I need help, like tell me what Pythagorean theorem is again, right? Tell me what the area of this triangle formula is. I'm forgetting my basic geometry. But if you have those kind of problems, Google Scholar probably isn't the right place to go. But it doesn't tell you that either, right? Here's another example about relevancy. So here's the counter argument, right? So you mentioned recency. So here's a company called OneFinder. They're based in Montreal, and I like using this as an example. Full disclosure: Elsevier recently acquired this company, and so we now are full owners of this company in Montreal, and they're working on some bibliometrics work to help improve the metrics around institutional output for science, as well as they have a set of tools that goes off and finds content across the internet that's not necessarily coming from publishers, that's open access content. But what they optimize here for, and you can see the example, is you can see that recency is 2019, right? This is boosting towards recency. So now I've got very recent content, but maybe it's not that good, right? So I searched this exact same query, machine learning algorithms, and I got a characterization of hill slope hydraulic events. So it's got machine learning in the title, right? But why is this the best answer? Why is this the best answer for me? It's got no citations. It's got like 2 social media interactions. So this is an example where recency can be dangerous, and we have to be careful how we blend these things together. Here's another example. This is kind of cool. So I go to Google Scholar and I can type in the word Michael Jordan, right? And if I go to regular Google, it knows that Michael Jordan's a basketball player and has a history. But here, this is referring to Michael Jordan, the professor at Berkeley. And so it knows right off the bat, again, I'm not logged in, right? It knows right off the bat, in this context, Michael Jordan's probably the best answer, right, for this query. But what's fascinating to me is the very next document is actually about Michael Jordan, the basketball player. And in fact, it doesn't actually talk about Michael Jordan. It's off the screen, I can't show you, but the fourth or fifth document is actually produced by Michael Jordan, the computer scientist at Berkeley. And it was interesting to me that it figured out, right? It figured out that I was looking for Michael Jordan, and that's probably the really good answer, but the first 4 or 5 documents aren't by that same person. So it was just interesting that they didn't choose to make that blend, right? And I think for, in this context, where we're looking for scientific information, why not make that assumption and make that leap and force that in there as an author?
Wikipedia would ask you which one you wanted.
Right. Yeah. But that gets to my very next point, which is this whole notion about simple and conversational, right? How do I set you up for success? I may not get it right the first time, right? But if I can't disambiguate, if I can't remove the ambiguity, let me just ask you, right? Let me ask you which Michael Jordan you meant, right? And then I can remember that choice for you, assuming we're GDPR compliant, and we all have cookies and all these wonderful mechanisms for doing memory. But that's when I get into this notion around it's simple and conversational. So I can simply ask queries. I can use simple words that I use in my regular job, in my day in, day out profession, to ask these questions. It's conversational because it gives you feedback along the way. It tells you, as you're building this experience, that am I going down the right path, or am I asking for things that are not going to give me fruitful results? So it guides me, helps me ask better questions, and just doesn't require me to know XML to format my query, which is just a little pet peeve of mine. So here's a similar example, Google Scholar again. So I typed in machine learning, and because I've been was probably preparing for this talk, I came across, it gives me a suggestion. It's autocomplete, auto-suggestion. It gives me a set of ways to refine what I'm looking for. Because actually I was looking for what are some better algorithms that are out there, or papers for algorithms that are out there that we can talk about that help me with either text classification or natural language processing or things that are more relevant to what we need to talk about. And so this gives me a really useful way to help walk me down that path and ask better questions. And as a consumer, as a customer, I didn't have to do a whole lot of extra work to find these options. I now went down and started typing text algorithms for, and I've got a whole set of options. Or I started playing text classification. So now I've got different ways to filter this query or explore different parts of the content without having to do a whole lot of work. Microsoft Academic does, even though they, for some reason, they recently changed their UI, and I think it's sort of hideous, but that's just personal taste. Maybe when we want to send some UI folks over to Microsoft or Microsoft Academic to help them. But what I really do like about it's, they've made it very simple to read. But what I do like about their interface is it gives you some other ways to explore this content. So here are some top topics that are really relevant to what you're asking for. Help me navigate this better. Here's machine learning for dummies. If you're asking a very basic question because you don't know very much about it, let me just get you started with what machine learning is and how we talk about it, and where it sort of lives in the hierarchy of information that we think about in this particular domain. It also, one of the things we're starting to see here, and this is something that I'm curious to get your feedback, is it's starting to do, they're doing some summarization. They're starting to identify keywords and tags that are relevant to this document, right? To help me summarize what this content is about, and help me understand what this result is. Give me a better sense. And you can see here, they heavily rely on citations again. So again, it's citation driven. Again, it's not necessarily. I think this is the second result from the citation count's a little bit different because everyone has as I found out over the last 9 months that's been at Elsevier, there's lots of different ways of calculating citations. Some are better than others. But it's looking at, this is sort of a seminal paper, and this is why it's coming up so high. has a large number of citations, even though it's not the newest.
But, I mean, I often find that with citations, if it's something like a library, then everybody cites it because they're just using it, and it really isn't a paper that explains things or...
Can I have your name and quote you? Thank you. I completely agree. I think citations is useful if you're, like, if you want to support a case and, like, I must be right because all these people agree with me, right? That it helps prove a case. But is this useful for getting the information, for getting to the stuff?
Yeah.
Yes, please.
It's actually useful for people who actually get the library. Because they get the citation, they get the credit for writing code. I think it's tremendously important.
Yeah, it's useful, right? It's useful for career helping, right? For understanding your career and how you progress along. I totally agree. It's useful for the institution and how to measure, and how the institution itself can measure scholarly output. But is it useful as for an end user to find the information you're looking for?
Sorry, you've got to be careful with citations because people in the field will cite, major people in the field will cite each other. So you might miss papers that are really useful but not being cited by key players. And therefore, you tend to find a lot of people who cite the same paper down the line. So if you get lots of citations, it doesn't necessarily mean it's a good paper.
Right. So is your point being that it's more important?
They're fine, but they're not necessarily a good way of finding.
Right. Yeah.
Certainly novel ideas.
You're never going to find novelty with citations. But completely agree. No, completely agree. The reason why I was asking on that question is it more important to say if someone in particular cited my paper, right? If a particular expert in a field cited my paper, is that more important than having everyone in the university cite my paper?
Well, if I'm just being a bit cynical on term and say you've got to find Professor X will cite Professor Y and Professor Y will cite Professor X.
Right, so you've got this
so
little bit of cross-pollination.
In a particular field, so it doesn't necessarily.
Which raises an interesting point about how do we do adjacent fields. Right, so you've got this, I'm going to talk about that a little bit because that's sort of my observation just looking at the data, is that there's a lot of self-clustering, right? But there's sort of like it's very small little fields, lots of little small fields. And so if I want to find out what's going on over there, how do I go do that? If I don't know these people, if I don't know that field. I think it's an interesting problem that we need to think about. Great, thank you for... this is sort of one of, I've been here, again, like I said, I've been with Elsevier for 9 months, and I clearly have come from a non-academic background in doing search. But these are, you're actually supporting some of my observations that I've made, and so I really appreciate the reinforcement of that. So thank you. This is just a quick example, again from Microsoft Academic, about how you don't have to memorize a complicated XML structure to perform your query. And what's nice about it is they actually show you, it makes it transparent how this query is going to be interpreted. But if you type in pattern recognition KD, it says, I'm going to assume this query means I'm looking for pattern recognition in this particular conference or particular journal, right? Which is not a bad assumption, right? Or Bert Vogelstein. So it's papers written by Bert Vogelstein. And that's something that Google Scholar didn't do, right? We typed the Michael Jordan, I didn't give a very explicit query, I just put the name in there, so it's fair enough. But now this is assuming that if I type in Bert Vogelstein and talk about molecular biology science, that I'm looking for papers authored by him about molecular biology in the domain of science. Does that resonate? Or does that feel like we're losing control? I'll leave that as an open question for now. The next key pillar around good search experience is authoritative. And I think my theory as to why most folks lean towards a Microsoft Academic or a Google Scholar as a primary place to start is because you can go to one place and ask your question, and you've got a survey across all the published material. So you don't have to pick out different spaces to start. So this gets into understanding the application that you need to use. And I put that particularly in the context of like something like Scopus from Elsevier or even Science Direct, which is it's scoped by definition to the set of content that Elsevier publishes in the Science Direct case. Or Scopus is, it's got a collection of content that's picked editorially, but it's not all content. How do you find novelty if an editor hasn't identified it yet? And so when I talk about authoritativeness, I think it's important that the data source you're going against is complete, has access to all the information you need, should understand what you can read and can't read, but regardless of whether you have access to it or not, whether, if you subscribed or your institution has subscribed to it, whether you have access to it or not, you should know that that paper exists or that content exists out there, so you can figure out how to access it. Whether you can just get an abstract, or if it's really important that you need to purchase that, or contact your colleague who wrote it and send him the copy of it through his preprints, right? And really can connect you with the most important answers. So this is an example, and I think the numbers out there vary, but 219 million papers. So this number on the top left. I think there's some debate about what that right number is. I've heard everywhere between 100 million to 200 million papers that matter. The number we use internally, and that may have some duplicates in it, is somewhere around 120 million documents that really matter. 664,000 topics. So how do I give a good illustration of how much of the iceberg have you really cracked?
Is that really like 300 million authors?
239 million authors is what Microsoft, this is from Microsoft Academic. How many unique authors have they identified? Now, is that correct? It's a lot higher than the numbers I've actually seen. And sometimes, and as you probably know from looking at scientific work, that it can be very tricky because authors are represented in different journals in different ways. So sometimes it's first name, last name, first initial, last name. Hopefully they're deduping that, but that may be inflated if that's not being solved for here. And this probably goes back over 20, 30 years. So
if it goes back, say, 100 years, then that may...
I doubt it's going back that far. It's probably going back to like the start of electronic journals, sometime in the 70s or 80s. Some go back to the 60s, but not that much, not that far back. That does seem high to me. But not before the just don't exist, right? Online, right? Yes.
Yeah, with the author names and stuff, you've also got the John Smith problem.
Yes.
The fact that yes, you might have duplicate names, but you might also have names that are belonging to different people that look like the same.
Precisely. We have John Smith, J. Smith, and then John Smith who belongs to Oxford University, or John Smith who belongs to Cambridge University. Different fellow, different institution, different field of study. So you need those are areas that help disambiguate author. I'm actually building an author autocomplete component right now, and we have that exact same problem. So how do we present it to the customer? How do we present it to the end user that's interacting and typing in John Smith, so you understand which John Smith I'm looking for?
Are you collecting ORCID at all?
Yeah. Yes. Yeah, all the data is tied to ORCID IDs too. So that's there. That at least helps for where people have claimed their ORCID IDs, and which covers a fair amount. But there are still journals out there, especially if you go into open access or things that are published sort of on the fringe, if you will, that may not have ORCID IDs yet. So which will create that problem all over again. And then the last point here is it just needs to be fast. It needs to be a really responsive website. Google has, again, broke the mold. I don't know if this is accurate or not, but I was playing around with Google preparing for this conversation. Google is reporting that they're returning their search results over 2 million results in 3 milliseconds. That's great, but no one else besides Google can do that, right? It's ambitious to get under 200, 300 milliseconds. A third of a second, half of a second is a good target for a sort of an enterprise document research system, but tenths of milliseconds, it's
already indexed. It's not like it's indexing it there then.
No, but it's even when it's context indexed,
yeah,
right? Even when it's indexed into a search engine, right? It's still quite expensive to get your queries down under a half a second.
It's just looking through your indexes, that sort of size of things.
Yeah, you're right. It's not indexing speed, because indexing takes a lot longer.
Yeah.
But Google will report that it's 30 milliseconds, 3/10 of it. It seems really fast.
They're not downloading on your computer. They're just saying that that exists in our servers. If you want to just click next.
Yeah, but it seems right.
Yeah.
Agree. And my point is, right, that sets an expectation for what, make your system like Google. How do you make it run it? How do you make it respond? Across 200 million documents in 30 milliseconds. No one in this room can do that. we can't do that. That armies and armies of machines, right? So, but it needs to be responsive, right? And so, yes.
If it took 5 minutes and came back with one document that was perfect, wouldn't that be better?
You tell me.
It depends.
Would you?
No, it's perfect.
Right. How do you know it's perfect? The answer is 42. Right. We've got the answer for you. What we find though on websites, right? If you're doing a website search, if we don't give a response back in under 5 seconds, people think it's broken or they've lost the internet connection.
It can tell you, I'm working it out.
Right.
I'm making progress.
No, it's that horrible little thing that goes round,
Right.
round until you get so sick to death of it.
Yeah, I'm going to go out and make myself a cup of tea. Maybe it'll be done. Yeah, maybe it'll be done, but maybe it won't be. I've lost faith. I think Sky's let me down again, and I can't believe my internet's gone out. Right? How do we trust it? How do we know? Right? There's different types of research that can be done. Right? I think in a search experience where I'm going off like this, and I'm doing a survey across content, it needs to be fast. I need it to be responsive. I need to know that there's something out there quickly, even if I'm going to refine it. That's my argument. If you're happy to wait 5 minutes, we should talk. I'm saying under a second is what I'm saying as a target. So, all right. So I want to ask you guys some questions now. So when you think about doing search, not geometry search, but when you think about doing search for scientific literature, and maybe I should even ask an earlier question: how many people in this room do search for scientific literature? Let me just get a sort of fair resume.
Does this include medical?
Yes.
Yes.
So medical. So I'm including medical. I'm including science, chemical, life science. Yes. So most people in this room are doing search. Good. Okay. I just want to make sure that was a correct assumption. So now, when you start your search, what is your strategy? Right.
You start with paper that's key.
Say it again.
You start with paper that's key, and
you start with a paper that's key.
Yeah.
So you find a paper that's key. You have that in your.
Yeah, well, you normally work with people, so if the focus is not out of science, they'll say read these papers, and you start from that point.
Start from that point, and then you look for authors from that paper.
Authors or titles or keywords.
Interesting. Okay. So I said authors. So a title, author, right? I have a couple of options up there. So you start with that paper. That's key, right? And then you go for keywords and authors by there. Do you frequently have the ID of that paper, or not necessarily? Like a DOI or ORCID ID of an author?
The bibliography on the paper that you like.
Or a book, bibliography at the end of the book or something.
Yeah, the bibliography at the end of the book. Okay, interesting. So you have that paper, and you want to start with that paper. You use that to go off and produce the research from there. How do you know? What other research has been done from that paper yet? Do you have access? Is that easy to find for you? And I'm talking about like if you look at general systems that are out there, is it sort of you start net new from that paper, or do you know there's a set of research that's already been done in that area that I can continue to pursue?
The thing is that even if you find the paper, you
Sorry.
have to pay for reading.
Hey, don't shoot the messenger here. I'm really just asking about the paying thing, the paywall thing. I'm just really asking about like the process of finding stuff. Assuming you had access to everything, right?
You start with review documents.
Yeah.
So you get reviews of multiple papers.
Okay.
And you go through a cycle where you look for whether you're picking up the same results. Eventually you get to a cycle where you're picking up all the same papers again.
Interesting. Yes.
You're assuming there that you actually have somebody friendly in the field who can tell you to read this paper. If you don't have that situation, which a lot of people don't, then my default would be going and start kind of searching by keyword and so on.
Yeah. Okay, that's good. So there's two basic strategies for guarding. One, you're working with your colleagues that can guide you, and it's a form of personalization, right? Identify, I'm in this field, I work in this department, I know these people. Here's someone can recommend to me, someone can push to me the key work I can start with, right? But it's a really good point. How often does that happen? If you don't have that key document, You start with keywords as titles. And you sort of hunt and peck until you find that document. Okay. So when you do your search, so 3 options. Do you do it yourself? Do you have a grad student or undergrad student that you say, okay, here's the research document, go off and pursue this document? Or do you work with like a trained librarian or information professional to go pursue that?
I do it myself, but just recently somebody told me that how much better they think librarians are. I mean, they were so impressed with how good a librarian could search because they're such experts.
They're experts of the field?
Yeah.
They're experts of the tools?
Yeah.
Yeah.
You can also find specific scientific librarians who don't know their subject.
So librarians. So that's interesting. So you use the librarians frequently?
No, I'm saying I do it myself.
You do it
but
yourself.
A friend of mine just told me I should really use librarians because they were so good at it. It's
Interesting.
better.
Yeah. So you're saying that if you find this subject area librarian,
Yeah, you normally find in a certain university library there will be a natural sciences librarian, maybe a computer sciences librarian. As it happens, the last 20 years I've worked in a particular organisation that's got its own library, and the librarian then knew more than most of the scientists.
yeah, interesting. Okay. Great. This is really good feedback. Thank you. And any particular favorites of tools?
How many have we actually heard of?
Or do you kind of just...
Some of them.
Okay.
And I have another.
Yes.
Alta Vista.
Alta Vista.
It's no longer available.
It's no longer
We read the
available.
documents.
Right. Well, because it found one. It found the one answer, and then they said, we're done.
Unlike Google, it actually read the documents.
Yeah. Alta Vista actually processed the information versus just looking at what people said about it. Right. All right. Yeah. It's a really good point. Yeah. Okay. So these are some. I talked a little bit about Google Scholar and Microsoft Academic. I gave those as examples. Web of Science is Clarivate's product. There's a couple of Elsevier products there. Okay.
There's a free one. Actually, a free one is Steele's all your articles, isn't it?
Yeah, that's that. Right, that number 6 up there, right?
Oh, right.
Yeah, that's the one. I know. Yeah, that's right. I'm not going to get into the legality of publishing tonight. I'm just curious if there's a tool that's better for use or something that you found a good experience. Yes.
So, I mean, my favorite is Google Scholar, but I find sometimes plain old Google is better because sometimes somebody wrote a blog or a web page that explains very nicely, you know, this machine learning concept or whatever. So you miss all the sort of scientific content that isn't sort of academically published.
Yeah, academic
it hasn't been published,
right.
but it's still very good.
You guys are wonderful again, because that was another theory that I had, is that there's probably some good blogs that are out there. There's good summaries, there's good web pages that take the reviews of the documents, pull them together, and say this is one of my favorite sites now is Medium. Medium does a lot of blogs, and there's this blog within Medium towards computer science, and they do a great job of just doing surveys of different algorithms that are out there, or they'll take a different technology that's coming and becoming new, and they'll summarize it and give examples around it, and they'll pull for key parts out of the paper, so it's sort of human readable, and then you can read back and you can go into the details in the paper. Okay. So summarization is helpful. Is that a fair statement?
Yeah.
So I heard sort of a couple things. Librarians can be very helpful. A lot of people do search themselves, right? I'm just summarizing what I heard. Correct me if I get this wrong. So you take it upon yourself to do it. Librarians can be helpful when they're domain experts, but summaries are very helpful, right? Human-written summaries. Have you ever run into, or would you know you've run into computer-generated summaries? This gets into like the Turing tests. How we know, right? If the summary was written by a computer or an undergrad or or a graduate student, which one is it useful? Okay.
Other summaries written 25 people, or is it mainly they're pulling out the abstracts and research?
Yeah. That,
What most is, any summary you see tends to be just the abstract.
right. You can get a lot from the abstract. But then if you want to do a survey across a couple of different, right? Okay. Great, I think I asked this question already. This is really tiny writing. So which describes you best? I want complete control and don't mind the complexity of building a query, or I want to make it easy to express my intent so I can spend my side reading and less time finding.
I think it just depends on the people. I would build up the query.
Okay. You wouldn't take the time to put control on the query.
Well, you need to take the time for the query, because otherwise you get so much return, you're never going to read it.
Right.
It probably also depends on what stage you are in trying to find out the information. So you probably start off with some broadly finding out things, and then you want to get more specific. So you probably switch from
general, depending on where you are in your research. That's interesting. That's really interesting thought.
There's probably a balance between those two things, though, isn't there? I mean, the answer is you want it to be as simple as possible to build a query, because, and the other thing is consistency of how you build a query, because when you go between various different systems, having to do things completely differently all the time, and you forget where you are because you're doing the query your way. Oh, God, I just do, so it's again, there isn't any kind of syntax that is agreed.
Would that be helpful?
There isn't a clear. Well, it'd be best if there was at least some core syntax that you could work to sometimes.
Yeah.
You obviously got Boolean expressions and things like this,
but still, interpretation of entities, as we've been discussing, is really open, right? What Michael Jordan am I talking about? What area of computer science am I talking about? How do we get more expressive? Okay, this is good. This is great feedback. Thank you. So this is a visualization of and it's drawn roughly, but you can see that around the outside are the high-level areas of science. So you've got physics, chemistry, so on and so forth around the outside. So each color sort of represents a high-level area of science. But what this is a visualization of trigrams, clusters of topics throughout the scientific domain that Elsevier is aware of. So we have there's a product that we have called SciVal. And they've created these topics of prominence, right? So what are the most frequently occurring topics? But one of the reasons I want to show this picture is it gives a really interesting visualization of the diversity of content, where each of these bubbles represents a certain number of topics. So this is a particularly large topic, but maybe it's 1,000 documents. Maybe it's 5,000 documents. It's not a lot. If you look at 100 million or 200 million documents as the set, and then each of those dots being the area. So when you get into certain areas of scientific research, it's really easy to stay clustered in your domain. And so how do we jump and how do we find connections across different domains? It's a real challenge. It's a real interesting problem to think about. But it's effectively it's a really long tail problem, right? It's when I was at Comcast, which is where I was previously, which is the big cable provider in the United States, who just recently acquired Sky, we had a massive popularity problem when Game of Thrones, which is on right now, the big show on home box office there, but Sky Atlantic here. When HBO is on, everybody's watching it, and so you've got this massive popularity problem. You've got this incredible signal because you can see everyone's tuning or recording or watching or playing on demand this show, and these things pop out. When I'm looking at data, and this is where I kind of reach out to this room and love to explore with your thoughts about it. When I look out to this room, when I look out to this domain of searching scientific information, there's lots of localities. And so the challenge that I have to do, that I have for you, is I've got to get you into the appropriate locality, and then once you're in that locality, then I can find really relevant information. But that's the two-step process. And so it's a really long-tail problem, which is why I surmised that personalization will help tremendously. If we know a bit about you, we know a bit about where you are, who your colleagues are that would recommend that paper to you, if I can get you into that location, then I can do a much better job of finding the most relevant stuff there for you.
Well, that is self-defeating to some extent, because
it doesn't want to be.
I always get the answer I want. There's a danger of that.
You don't want it to be. You're right. You don't want it to be a filter bubble. So you want to easily be able to pivot out and say, like, no, I want it to be in this domain, or I don't want it to be in this domain, right? That sort of that conversational notion. So I always have that escape valve.
I mean, the Facebook problem.
It's the filter bubble problem.
You get to hear what you want to hear,
right?
So that there's a danger of that.
Right.
So with personalisation, to be clustered into one place,
yes,
can actually exclude you from seeing something that you would like to have seen.
Right.
Because
you've got right.
What are you going to know about this?
You want to get yourself into the bubble when you know you're there. You also want to be able to look around you, right?
You need both.
Yeah, you need both.
So what's the edge to centre axis shape? Is it relevant to other fields? So that big red block in the middle, why is that separate from the rest of that?
Oh, that's a great question. Yeah, this is something in the medical domain. Sure. I'll go back and find that out. Yeah, distance from the edge, but I think it's sort of, I think it's the uniqueness of the taxonomy. You can see this is sort of broad. There's a large number of topics in this area, so it's the uniqueness of that, because it's a trigram. So I think it's the uniqueness is the center. Because it doesn't mean it's necessarily closer to one of these guys, but it's just further away from medical. Okay, so problems, search problems. Welcome to my day job when I think about search. So here's a little bit of a search maturity model, right? When we started to introduce search, enterprise search, as we call it for a number of years, or even website search, we started with very simple techniques. We created an inverted index, right? This is what a search index does. This is what Solar does out of the box, or Lucene, or any of the search products that are out there. They look at TF-IDF, term frequency, inverse document frequency. So how often does a term occur, right? And then compared to its relationship to the number of documents that have that term. BM25 takes that TF-IDF, which is, again, sort of the core tenet for doing document search in a search engine, and says let's really focus in on the top 25 results. But these are sort of the basic techniques. So if anyone that's building a search experience, this is where you start. This is where most search experiences start today. And if you throw on a search engine out of the box, arguably, if you open up any search engine out of the box, these are sort of the basic capabilities you have. Elasticsearch will have these capabilities. Then we start to mature a little bit. We start to identify entities. We start looking at taxonomies. We start looking at ontologies, synonyms, dictionaries. Right? Those are techniques that we use within a search engine to help us understand better about what's going on and build better information about the particular domain that I'm focused on. How do I tag my content for a particular domain so I can get consistent tagging and representation within that particular domain. But the next couple of areas that we're going to spend some more time the rest of this talk chatting about are this next notion around querying intent, and I spent a little bit about this. These are some, given where compute is today, and given where some of the algorithms are and the speed and performance that we have with network latency and computing power, there's a real lot of opportunity around doing querying intent, which is I can now spend some time really understanding what you're asking for to help you ask better questions. So this is things like query classification. Where does this query belong? What domain should I route this query into? Disambiguate the query versus disambiguating or understanding the content itself.
Can you separate those two in a way? I mean, it would be useful on occasion to be able to specify the intent for some research that you're trying to do, and then do queries within that intent in some ways. So I can see that the expression of intent is a very good way to increase the relevance of the query.
That's right.
So being able to specify intent in some way separately, but have a group of queries that then aligned to intent.
So that's that. I think what you're describing is exactly how I envision a good search experience. It spends the time allowing you to express your intent more fully, right? If your intent is vague, if you come up and say, I just want documents about marketing, well, what does that mean, right? But how do I give you a system that comes back and says, let me express your intent more fully. Let me allow you to classify your intent, to figure out really where this query is going. And then once I understand that, then I can use query expansion to expand into synonyms that are relevant to that domain. Right. So we shouldn't expand too far. We shouldn't use techniques like query expansion or synonym expansion until we really understand the intent. That's precisely right. And that's where I want to get into some of the techniques that we can use to look at that. So if I look at where my world lives, even where I am at Elsevier, we're probably we're in this world in terms of maturity, in terms of the tools that we have. And let's talk about the tools that I work on a daily basis. This is Science Direct or Scopus. We're living in this world. We've done some interesting work, and I showed you a picture around the representation of concepts or taxonomies, or more concepts, a concept cloud map, if you will. This is the next big opportunity, I think, that we have in front of us, is really spend some time doing that query intent. Right? And then we can get into some of the interesting things around A/B testing. How do we actually A/B test relevancy models? How do we actually leverage neural networks, leverage machine learning, leverage deep learning to produce better relevancy models, including things like learning to rank, which is now starting to be quite popular as a relevancy algorithm. And then there's just sort of this future state where the machine just learns by itself. It's just self-aware, right? It's aware of all the content.
Self-learning is machine, not human, is it?
In this context. Sorry, yeah.
The context is quite important.
Yeah, you have a very, very good point. Yes. Well, should the human be more self-learning, or where should we adapt?
Humans redundant.
That's right. Elon Musk is proving that right now, right? Okay, so I'm going to dive into a little bit about a couple of search problems. So here's the one we were just talking about: understanding intent, looking at language, relevance, refinement, and content. So understanding intent. So this is what we were just chatting about, right? How do I enable a system to uniquely express what I mean? This one's sort of a bit of a pain point for me as I walked into my current role in Elsevier, and some of my colleagues said, we've got these researchers, we've got these customers throughout the world who've spent months, years perfecting their queries because they're from the University of Pennsylvania in the United States. And it turns out there's just a lot of ways that we express University of Pennsylvania. We have Univ of Penna, University of Penna, U of Pennsylvania, so all these different variants. And so the researcher took it upon themselves, the librarian took it upon themselves to capture all those different ways of expressing the University of Pennsylvania, encoded it themselves into the search query because they didn't want to miss anything, and they really just wanted to know how many documents did our institution put out. That really was the question they were asking for. So I think I would argue that that's a poor way of expressing intent, right? That's an example of what we don't want our customers to do, right? We want, if you start typing in Univ or Una or Penna or Pennsylvania, we quickly want to be able to say, oh, you're talking about University of Pennsylvania. It's located here in Philadelphia, or State College, Pennsylvania. Is that the one you're talking about? Yes. Right? Now I understand your intent. I know what you're talking about. We'll represent that as an ID behind the scenes. And all those strings go away, all those variants. So now I have to do is tag my content with that ID space, match that ID. So I match that ID in the query, match that ID to the content, and now I know that every time I make that query, I'm going to get all the right content back versus having to reinterpret it. So that's an example of ways it's better. We can express our intent better. Similarly, about removing ambiguity, right? I just gave the example of Trinity College, where I attended, which is not in Ireland, right? But it's actually in Hartford, Connecticut. So how do I remove that ambiguity? Michael Jordan is another example about it. So quickly allowing customers to say, or John Smith, right? The John Smith example. I type in John Smith. which one am I talking about? Give a conversational system, allow you to pick the version that matters to you, and then map it to a known ID space behind the scenes, right, that can then be used. And then this is really important. This is where we get into the relationship of these words, is how do we understand and map that semantic relationship of that concept. And here's an example, right? Oh, my build didn't work. It was supposed to build out nicely, but if I say ring, right? Ring, if I give you the word ring, so if I go with search query for the term ring, I just want to measure my quality by giving me back every document has the word ring in it, right? Well, what if I meant, please give me a ring, versus he gave her a ring? Those are two fundamentally different uses, right? So if I bring back content, if I'm looking for content about people making phone calls or making telephone calls or calling on your mobile, it's very different from someone giving a marriage proposal. And so how do I get to that intent? How do I get to that understanding? Languages, this is sort of the classic example of search query problems. Understanding specific language problems. So spelling, grammar, various language variants. I've learned quite a few since I've been living here in the UK. We have these normalized word localizations of color versus color, or theater versus theater, right? Just how you spell things, and those are somewhat rules-based. We can put rules around those. We can put a system to capture those things. They're known, right? They're known, and they're captured in a lot of the dictionaries. So those aren't too bad. We can do those translations fairly straightforward, even at query time, right, or index time. But then there's sort of new emerging technology, right? Something comes out as, how do I know that this is Google's being used as a noun, right? Google the company versus I went and Googled that, right? How do I know what that intent is? Or how do I know how I'm using that word? And then there's sort of these really highly localized country to specific. I'm learning so many that there's all so wonderfully colorful, right? Boot versus trunk. Trunk is what we call the boot in the States, right? Lift versus elevator, and of course Q just getting a line, right? Lining up. And so how do you map those? How do we? So a search system needs to be aware of those, but understand how those semantic relationships between those words. What's really starting to be interesting in some of the areas of interesting research now are especially where machine learning started to help us a lot, is what we're seeing now that it's not just good enough to recognize the entity and disambiguate the entity. It's also more important to understand how that entity is being used. And so it's not just the noun phrase that matters in natural language processing, but it's the verb and the noun together, right? Or even the subject, object, predicate together that really start to give us meaning. And so how do we build systems that think about that full understanding of a word? So relevance, we talked a bit about this before. These are, again, search problems, because there's lots of ways to rank things that are relevant. What's relevant to me, what's relevant to you. This is, I've covered this a couple times before, but this is sort of the research saying I want the latest content versus I want that seminal document, right? And I think the intention of using citation as a ranking function in scientific search applications is to try to find that document that your colleague referenced to you. That's the intention. And the question that I want to ask is, how successful is that? How useful is that? Or is it more useful to go talk to your colleagues? Right? And again, if we ask for by Michael Jordan or documents about Michael Jordan, how do I allow the system to express that? What am I meaning here, right? The last bit here is this notion around refinement as another search problem. This is where we get into this notion of conversational. And so this is, again, this one finder area. But we talked, when you do a search query, refinement should be just point and click, right? Like that, or like that Microsoft Academics, where it just gives you the topics that allows you to dive into. Where you type a few words and the autocomplete just fills it for you. And then finally, another search problem around search content, search problem is just around the content itself. We're talking with some folks out in the hallway that just about tackling their own search problem, there just isn't consistent metadata. Even when you look across scientific, even scientific journals, authors and people that are writing the content tag the content themselves, so that it's not consistent. They think about it in different ways. Abstracts are written in different ways. Content enrichment itself is done differently. So we'll have content that comes into the organization. They'll process it through a sort of traditional classification routine to tag it with a set of content. But the reality is that you can actually apply multiple content enrichment processes to it. You can tag it for a medical domain, or you can tag it for a scientific domain. Each of those domains add value for that content. So how do we do it consistently as we approach our search system? And then finally, how do we do effective summarization? So, all right, moving through. So those are some content problems, right? And so fundamental language problems, and problems with the content, and problems with expression. When you think about search itself, there's lots of opportunities now in a search system to use things that are not necessarily content related. So we talk about these as there's the system of record, which is here's the document itself, here's the authors, here's the institution that produced this work, here's the title. Those are things that don't change over time, right? And what gives us an interesting experience, or ways to get this content shared in a more relevant way, is now looking at those systems of engagement. How do people engage with this content? What matters as they engage with it? What queries do they run? Right? When they actually ask a query, what queries do they? If they execute a query and then they click on a document, I can now start to build relationships between what they ask and what they click on. That's an engagement system, right? And that may change over time. People might ask different questions. But if they ask a different question and then they connect it or read a different piece of document, I now can start to create those relationships. So I can look at those interaction patterns, queries, click-throughs, the reads, the downloads, annotations, notes that I make across content, just to look at different ways that I can engage with this content. I can even save stuff in my own personal library, share it, or talk about it. So let's talk about a couple of examples here. So search queries. When I look at a search query itself, it presents an expression of intent. So I've typed in some questions into a search system. I've either asked them with a keyword, or I've used my voice to express my query, right? So it enables me to express my intent, and it captures a specific question that I'm looking for. But as we talked about earlier, the search query itself may not fully express the need. It may not fully express everything that I need, right, to capture, to understand the meaning. So it's possible to be misinterpreted, and it's also search queries themselves. It's just an input signal into our sort of our. I'm just talking about the signals that we could use for like a machine learning system or a machine learning algorithm. Those systems can be gamed. So if you have an open website, a search engine optimization or search marketing or robots can go through and send the same queries over and over again. And suddenly these queries pop out as being important, that you're getting large counts, but there actually aren't really people behind them. There aren't real humans actually doing those queries. And so looking at queries in isolation as input signal into our machine learning algorithms can be dangerous.
Can I go back to a minute ago you said something about keywords versus speaking, but when I think about when I do search, that when I speak I often will give a full clear sentence, and I would say maybe something by Michael Jordan, but if I was just typing, I often just give keywords that might be more ambiguous. So, and I know people remark that often a query is better if you express it as a full, complete, clear sentence. And maybe that's also why librarians are useful, because when you tell a librarian what you want, you're not just giving her a few keywords.
Right.
Or
yeah.
Well, I must admit, our librarians, what they tend to ask is, can you give me an idea what you want and a set of keywords for us to search?
Right. So the librarian's helping you do. They're helping you formulate your query better. And you're right. When we talk, when we speak, we're speaking full sentences. But when we write, we take a shortcut.
And therefore, the intent's a little more obvious with the spoken.
Right.
one thing going through my mind is the coherence that you get for search if you use machine learning. You know, a lot of people are doing the same queries. You can optimize that with machine learning, you know, logically, right? But if things are very different, then what am I optimizing for? What is my optimization? Yeah,
right.
And I can be in completely the wrong space. So how, when you start, maybe you'll get to that, but I'd like to understand maybe at some point, because that's your subject, how you optimize this, because it seems to me that there's a great diversity in the academic community about what they want, and there's also
and that's actually both. That's a really good observation. I think that's the point here of this part of the talk right now, is that there's lots of different signal, but in isolation, each of them can be dangerous. Right? And so how do we build a system then that connects these things together? How do we build a system that helps us evaluate which are the most important in this search journey? If we're now going to build a machine learning algorithm that's going to go tackle this, right? How do we identify what these pieces are? Yes?
You mentioned bots. Were you suggesting that there are organizations that are using bots to improve their Google ratings?
So that's probably out there. I wouldn't deny that that's happening.
Okay.
But I'm also suggesting that there are bots out there that go against repositories of content and ask the same questions over and over again.
Yeah.
Right?
For what purpose?
Either to pull information, so they go and they download, like perhaps the competitor that was identified earlier that is offline. So people are going and pulling contents in large swaths of information and downloading it and copying it somewhere so they can redistribute it. Sometimes certain institutions will just pull down the content just so they can take it offline and do some analysis themselves, right? Sometimes it's All right, so the next area of signals is this notion of click-through. So you do a search, I give you a set of results, and then I can compare that or connect that to what you click on, right? So this now starts to reinforce this notion. So in this example, if someone's come and asked for marketing, and every day they come and ask for marketing, and even if it looks like it's coming from dozens of different sites across the internet, but they come and they ask for this term marketing, but they don't actually download or click something, that indicates to me now that search signal, that query signal, which may have expressed useful intent or was quite popular, may actually be completely meaningless. Because I can't now connect it to an activity. I can't connect it to a call to action. I can't connect it to something that's valuable. I saved this document, I stored this document, I put it away somewhere. Right? So that's a way that I can now start to take this system of inputs and start to refine it.
Isn't that a weakness, though? Because if I do think about search, you do a search query, you click on things you want to do. If they're not relevant, you don't unclick them. Some search things, it'd be far better if you could, once you start to know what you're doing, you've been able to put in a statement saying, I don't want this. I don't want this.
Remove this from my system. Right? And that's negative feedback. It's actually quite useful. It's useful for recommender systems. If I'm generating a recommender system and I'm a recommending set of content to you, it's just as useful if you say, yes, this is good for me, and no, this is not good for me. Those are quite useful things. But one of the things that we see in our systems today is that we have clicks, right, which maybe just look at the abstract, or maybe use the hover to see who these authors were. There's downloads, right? So in this case, I went and did a search. I did sort of a vague search, or I did a survey search of sort of new things in my field. I just pulled out the top 25 or top 50 things so I could put them on my hard drive or my personal library so I can sift through them later. I can do my own analysis later. I've got stored a library, so is that meaningful? I've got this notion of I've even got this notion of here, I'm going to talk about this right here. That was my slide. Thank you. I got ahead of myself. But so there's multiple forms of what matters, and that's the question that I have is which of those are signals, right? Which of those create signal for me, and which of those are just creating noise? If someone goes and takes every single document in the result set and downloads it and saves it, is that a valid signal? Should I count that less than someone who actually took the time to read it? Or maybe went back and forth and read it multiple times. Maybe it's that secondary access that's more important. And negative signals, if I skip over something, what does that mean to me? Do I skip over it because it's not relevant to me? I see it's either it's a paper I've already read, it's maybe it's a paper I know I don't have access to. Right? I know it's coming from a site that I know I can't subscribe to, so I'm just going to skip over it. So what is the meaning of that? We have to be very careful when we look at these interactions. They're signal, but they can be both pro and con. So there's also this notion of sharing. So Elsevier has a system called Mendeley. There's also this system out there called Twitter, right, where I can take my documents and I can talk about them. They create some interesting opportunities for signal. So I'm talking about my document, or I'm discussing my document. It could be, hey, this is my first paper. Isn't this great? I managed to publish a paper out there. Or, hey, this is a new paper that I heard about at a conference. I thought was really neat. We should read about it. So there's some interesting positive signal there. There's also some interesting sentiment there, though, because in Twitter, they're not necessarily using full language. They're using maybe shortcuts, or they're using hashtags, or things that have meaning to them, but don't necessarily have meaning to a system that wants to interpret it. So how do we look at social signal as an input into this equation? And then finally, there's this notion of human judgment. And human judgment's fantastic when we can achieve it. So if I can actually ask someone who's an expert in a field to run a certain set of queries and evaluate the sets of things that a search system gives back to them, that's fantastic input. It's really, really hard on my side of the world to scale that. Because it's really hard to find people that are, willing to contribute to do that. It's hard to get people to do that consistently, because we're humans. It's hard to do it across a large number of fields. So if I'm building a search system that wants to connect multiple different domains, I'm going to have different expertise in different pockets, as we saw in that picture. And it's hard to get good coverage. And that's why a real search system will take a look at sort of all these signals. And the approach we want, what we surmise is that we can take machine learning algorithms, we can look at those patterns, we can look at those interaction patterns and figure out which ones are additive and which ones are negative. And it's going to depend on your application and your context.
So which machine learning methodologies are the major ones? When you use supervised machine learning would mean I would have some kind of an export or some kind of thing. An unsupervised one would be clustering, or a reinforcement one would have some kind of reward.
Yeah, and
I'd be interested in your thoughts about which particular methodology you think would be appropriate.
And the answer is right. It depends on what part of the problem I'm trying to solve.
Right.
Okay. So, for example, for classification, and actually this is I'm getting into the point of it here. But I think I have some slides to talk to this. I'm going to summarize this bit, and I'm going to get it right to that point. The summary here, right, is some signals are better than others, right? Okay, so how do we combine them? Let me move on to the next bit. A couple of different areas of machine learning. When we talk about artificial intelligence, I'm not smirking to be controversial, but like artificial intelligence is really used broadly to describe a large number of capabilities. Everything from sort of simple feedback loops, right, machine learning, to full-blown deep networks and neural networks, right? There's this notion of natural language processing, which allows me to apply both rules-based as well as machine learning and semantic processing to look at it together. I want to answer your question, but I'm going to get there in just 1 second. Let me skim through these real quick, and I'll get to that. Okay. When I think about the whole problem of natural language processing, there's three effective domains that really matter here. One is a rules-based approach, which is where we start. We start with a taxonomy, which is kind of more of the supervised notion, right? Machine learning is very broad, so that covers a lot. Semantic processing can also be this understanding and notion of and distance and location, right, from each other. So let's start real quick with just a rules-based system The rules-based systems, even though they're sort of older and more original, some of the more traditional ways to process search engines, they're still really important for areas like around classification, entity extraction, language variance, looking at problems like lemmatization, right? So when I have different conjugations of words, different conjugations of verbs, like those can be captured in a set of rules. Language fundamentally doesn't change. And that's where rules or very highly supervised systems that are engaged are still really important and still very useful for a search system. There are a couple of interesting machine learning techniques that are really starting to emerge in this space. So I'm going to talk about those real quick, and then I'll talk about the application of it. And that's what I had left to talk about today. I highlighted a couple. There's probably a lot more tools that are out there, but these are a handful that are starting to emerge, that have emerged over time. They've really drawn some interest. The first one was this notion of word-to-vec. So you're talking about geometry earlier. I thought this was what you were talking about, right? But the whole idea here was, the idea of word-to-vec said, listen, we've been looking at term frequency as a way to measure the relevance of documents. And we've been looking at how often a word appears in a particular piece of content or in a particular corpus, right? And we look at just how often that word occurs, and we use it as a way to figure out how important that word is to that document. Well, then what happens is I try to normalize that over different types of content. What if I've got content of different length, right? So I've got an abstract, which is maybe a couple hundred characters, a couple hundred words, 500 words, maybe 1,000 words, or I've got a full text, a full journal, or a full research, encyclopedia or a textbook. That word is going to have less importance that document with longer content. So word-to-vec says, let's create a mathematical representation that allows me then to say, for any given word across this corpus, what's the value? And then I can look at those two different words, and I can see how related they are. So this notion of, I can create this relationship between, for example, this is the classic example of man to woman, and then I can infer that there's that similar relationship between king and queen. They're both a royalty, but there's this male-female relationship. Similarly, you can look at verb tense to create this mathematical representation, or even things like, so we start to get into this notion of embeddings, right? This notion of state capitals to states, or zip codes to places. This now creates a mathematical representation of the content within our system. Facebook, whether we love it or hate it, created this really interesting tool, right, called fast text, which is actually quite fun if you haven't taken a look at it to go play with. But it takes a look at two of the key machine learning algorithms that are proposed in this word-to-vec document. One is looking at a continuous bag of words, which says for a given sentence, any word in a given sentence, right, is related to one particular word. So I've had a sentence, for example, that says I'm selling these fine leather jackets. And I want to take a look at the word fine in relationship to all the other words. The continuous bag of words says, I now have a set of words that now can relate to this one document. So it's nice, but it creates a relationship between those words, but it totally ignores the sense of order, right? However, there's another algorithm that's here called skipgram, which now creates a one-to-one relationship, but it ignores the distance, how far apart they are from each other. And so it turns out that both the order and the distance are both really important. But fast text is great because what it can actually help you do is it can actually help you look at, for any given word that you suggest to it, it can give you a suggestion of other words. So it's a really good application for an autocomplete or an autosuggest, right? When I want to predict what the next set of words will be based on the words you type in, these capabilities actually work really well. So even though they create some distance problems in terms of real meaning of what your intent is, they're really good at looking at the probability of what the next set of terms will be. So the word-to-vec is really useful for now creating relevancy across different sized documents and documents from different places. Fast text is really good at building these summarization techniques. These techniques for building really conversational and simple experiences can now be done with fast text. And finally, next is this notion of Stanford Glove, which combines a whole set of natural language processing tools. One of the interesting ones is this nearest neighbor. It does a couple other things as well, in addition, but one of the ones I want to highlight for you was this notion of nearest neighbor. So looking at a set of documents, or a set of words, what are the closest words to the input word that I give it? So the example here is, it's gone and looked at, like say Wikipedia. As an example, I give it the term frog, and of course, as you'd expect, frogs and toads come out as really near terms, but then we can also get the scientific terms, so Latoria, and I can't pronounce this. These are other scientific terms of frogs, and this helps us with the problem of image recognition. So now I've got an image, right? I search for the word frog, but now I can bring back images that are closely tagged with these other terms because I've looked at this notion of nearest neighbor, right? And so this is how I can now start to do an image search problem. Okay? And finally, and I'm skipping through many other advances, but one of the big ones that's starting to come out right now in the world of data science is this whole notion of BERT. And this is sort of the one that's transforming a lot of conversations right now. And what BERT is doing, which is unique and very different from any of the other vector-based or embedding-based capabilities that are in the market today, is BERT is one of the first neural networks, machine learning networks, that's actually looking at the relationship in both directions. So it looks at not only, it doesn't read just from start to end, just like you would read a sentence, but it thinks about the relationship from words backwards as well as forwards. This is useful because, as we talked about earlier, right, again, when I talk about this notion of Trinity College or Naval Research Laboratory, you have context for that now. You remember, well, it's been almost a good hour and a half since I started this conversation, right, that we mentioned these things, we talked about these things. So as we think about humans, as we think about communication, as we think about discovering systems, it's important to be able to relate back to that, to that earlier part of the conversation. And one of the things that BERT is really good at is filling in missing pieces when you mask out certain other pieces. So, for example, if let's see, where's the example that I had? I have it in the document. I have it somewhere else. So, when you mask out certain words in a sentence, BERT is actually really useful at creating question and answer systems. So if I want to create arbitrary questions, or if I want to ask summaries, I give it a piece of document, I give it a piece of content, and say who was the action that actually took place in this. BERT is actually really good at figuring out who was the action that took place, what action took place on them, and how did that happen. So BERT, even though it's sort of expensive to train compared to the other systems, it actually gives tremendous results. It's one of the few, and this is again released by Google last year. It's one of the few search engines that's out there, or machine learning algorithms that's out there, it's really as a generalized machine learning algorithm. So it's trained on a generalized set of corpus, but it has, because it's so generalized, it has this rich connection of understandings using transformations internally. It allows it to be reused for some very dynamic different purposes, including questions and answer systems, as well as auto-suggestion and autocomplete purposes, as well as it actually is outperforming humans when they do some of the same tests that are done in the SCLU benchmark, which is a standard that's being used to evaluate search systems across the industry. So, quick survey of some of the capabilities that are out there. Finally, to tie it all together, feedback loops are great for simple things. We talked about click-throughs. We talked about being able to implement auto-suggest, re-ranking, autocomplete. We talked a bit about hiding content that I've read or not read. Just a quick, simple feedback loop that I can learn from. Right? Even learning to rank at the end of the day is really just a feedback loop. It's looking at what your activities are. It's looking at what you've done in the system, and it's improving the ability to present that to you on the screen. Also, the ability to reorder filters or facets on the side. Classification is another area of focus. This is an area where we can use both supervised as well as unsupervised techniques. And I think the key thing with classification, which is really important to understand, is that it's a combination of both the supervised techniques as well as the unsupervised techniques, which is the key to doing both good classification at the content side as well as the query side. The reason being is that the supervised taxonomies, those domains don't really change much over time, but they're really expensive to maintain. So you can build a taxonomy that defines an animal hierarchy, for example, or a domain of science, right, or an area of mathematics. Those managed and supervised taxonomies are fairly static. But the unsupervised are really useful to combine because they learn novel techniques and comments and new capabilities, new things that are being discussed, and need to be added into that taxonomy. Blending those together becomes a very powerful capability. Yeah. So that's an area that we have there that we can look at for classification. This is I think things like BERT, things like deep neural networks are going to be really useful. We talked a bit about this whole signal classification. How do we take all these usage signals, these engagement signals? How do we combine them into something that really matters? This is where the deep learning comes into play, right? So we give it a bunch of inputs. We tell it what good is, right? We either use human judgment or we use some form of evaluation to tell it what good is, and then we let the system now come back and tell us how to combine these and how to rank these. This becomes very powerful for us. So systems like BERT, systems like that, deep neural networks are really good applications for this. They require a lot of data to go in. They require a lot of processing power, but they can give us really powerful outputs to control the experience. And then finally, we can also build a really good question and answer system. Some of these questions have been asked before, and they're somewhat trivial. Like, what is your favorite color? Or the average airspeed velocity of a sparrow. Those questions have been asked before. Or even, what is the meaning of life, right? Those it's a broad one. But what these systems allow us to then do, and this is where BERT can shine as well, is it actually allows us to ask these complex questions through our voice, through our keyboards, through our systems. Like, for example, what are techniques for natural language processing? What are good techniques that work out there? How do I find that? Is immunotherapy for treating cancer effective? Right? Those are important questions that we have that we can now start answering by pulling these systems together. So, all right, that went a little bit longer than I expected to go, but thank you for all the interactivity, and that was all I was going to cover today. Thank you.
Thank you very much. We've almost run out of time, so I think we've probably got time for a couple of questions, but that's about all. Has anybody got anything that they haven't raised before?
I had a really good question about the English Civil War, but I'll shorten it. On the flip side of personalisation, I'm minded that Elsevier was owned, not so long ago, by a megalomaniac crook. And you're collecting all this very powerful personal information about pinko academics. How can we tell, since we know GDPR doesn't really work, that the information is going to be handled properly?
Right. And that's a fantastic question. I think as we look at information systems, and we look at building search systems, the key thing to establish a system where people can come and they want to work in and help evolve science and make science more effective is we've got to establish trust. We've got to enable you as a user to understand what is being kept, what is being used, and how is it being used, and that has to be relayed effectively back to the system. And again,
your brand at the moment isn't just a brand.
Back to the customer. Sorry, not back to the system, but back to the customer. How are we using your data? Like, for example, if I recommend a particular journal for you, right? I say you should read this particular journal. We should also say we think you should read it because you read all this other content. That helps us establish this trust factor, right? Of why we think we're making the recommendation for you, right? So it needs to be valuable and it needs to be trustworthy. And I'm not going to stand here. I won't stand here today and say that the company that I work for today has done all the right things. But we need to. That's where we have to go with our systems, and it's where we have to go with our systems that are doing social media today, right? So if you look at the Facebooks, you look at the Twitters, you look at anyone that's out there collecting gobs and gobs of data about us, they have to be transparent and trustworthy as well. And so how do we create that transparency, right? How do we GDPR is being sort of newly exposed to it. I know all it seems to do is pop up another box that I have to click on, right? And I'm not sure it's gone much beyond that. It has the threat of saying you have to be compliant with it, which means you have to do reporting against it. But how do we build that trust with the consumer so they really trust the system and want to engage there, right? People did that in Facebook and Twitter before they understood how that data could be used. And we're starting to learn now how powerful that is. So personalization is going to be, really to answer your question, it's going to be a hard nut to crack. We can't just flip the switch and start capturing all this stuff immediately and make the experiences better. We've got to demonstrate for our customers and for users that it's a better experience and that we can also, it can be trusted.
Any other questions? In which case, I'd just like to thank Erik for illuminating.
One more geography.
Oh, you've got one there. Sorry.
Geology problem. Geometry problem.
Sorry, my question is about natural language processing and clinical data, because you mentioned maybe the natural language processing can help for some decision making. But what about in clinical context? How can we make this data very reliable? Because this is about patients. How can we make it reliable and make these techniques developed in this field?
Yeah, so that's a great question. So the question was in the field of the medical field, when we're trying to create applications for clinical use. How do we do natural language processing in a way that can be done for that's trustworthy and for clinical uses? And so natural language processing and some capabilities. So not to just to harp on some of our own products. Clinical Key, for example, is the Elsevier product that they use for delivering journal information or scientific information to the clinicians at support time. It uses semantics, but it uses semantics of natural language processing purely to do some semantic expansion, right? So it's not doing, as far as I know, they haven't really begun to do real query understanding. But what they're doing is if you ask a question like heart attack, right, it knows how to expand heart attack into the technical terms. I don't know them all off the top of my head. That would be used in a journal or be used by a doctor to describe the symptoms. And that's stored in a supervised capability in a taxonomy, right? And that's how we're using natural language today. And so that's very one-directional, right? We're not really taking anything personal from you. We're not taking anything personal from the customer, right? But we are providing the ability to ask questions in simple language and then get detailed answers for it. But we can do that in the context of something like Clinical Key because we know that everyone that's there, that's using that system, is in the medical profession. And so it's fairly safe to do that expansion aggressively. And there aren't a whole lot of domains that we're covering there. Okay, so that's how that works today. And so it's safe in that it doesn't take anything from the patient, right? It doesn't infringe upon any patient's rights. It's just doing that understanding in the back end. Okay. Now, I think there's a lot more we can do, right? If we can allow normalized or sense or clean patient data, learnings, like if we can take summarization or we can take clinical work or clinical data, that trials, right, and we start to let our machine learning algorithms start to learn from those. We can start to figure out which of the research actually led to good decisions, and which of the research maybe led to maybe a red herring, right? There was a really interesting. I'll wrap up here. And it's getting late. There was a really interesting story that one of my colleagues told me about SIDS, the sudden infant death syndrome, right? All the symptoms for sudden infant death syndrome were actually captured in the literature. they'd been in the literature for 10 years, but it didn't surface until a doctor or a patient was able to make that connection 10 years later until they observed that happening, or there was a rise of it happening with actual patients. So the opportunity that we have with looking at the scientific data is we can make those connections earlier in the process. There's a possibility that we can save lives, but we have to do it in a way that's trustworthy and safe, and we're not infringing on people's rights. And I think that's the fascinating opportunity in front of us that we have to solve, is how do we do that? How do we identify those problems early on so we can surface the right information to the right people in a helpful way? So, long answer, sorry.
Well, thank you very much, Rob. I'm afraid we've run out of time.
Yeah, we've gone over. Thank you for your patience. Thank you for your interactivity. It's been wonderful. Thank you. I really appreciate it. And thanks you for all the candid answers about how you do your jobs, or how you look for content on the internet. I appreciate that.
Thank you very much.
Thank you.
Thank you.
Good night.